Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 6 from Chapter 2, which is looking at applying the trigonometric ratios. So here, we're going to be looking at solving problems involving all three of the primary trigonometric ratios that we looked at throughout this whole chapter. So one of the questions you might be asking is, how on earth can we remember all three of the ratios, and then how do we remember or how do we figure out when to use each ratio? So one thing that some mathematicians or somebody came up with to help us remember the three primary trigonometric ratios is something called SOHCAHTOA. SOHCAHTOA. So when you write out SOHCAHTOA, this tells you the ratio and which sides are involved for that ratio. So in SOH, S-O-H, we have the sine ratio, so sine of theta is equal to your opposite over your hypotenuse. In CA, we have cosine of theta is equal to your adjacent over hypotenuse. So A stands for adjacent, H is hypotenuse, and then TOA is tan of theta is equal to your opposite over your adjacent. So when you're reading this SOHCAHTOA, this always reads in the exact same way. The first letter is your ratio. The second one is the numerator of your fraction. Then the last one, or third one here, is the denominator of that fraction. So S is in your sine ratio, O is opposite on top, and then hypotenuse on the bottom. Cosine, adjacent on top, hypotenuse on bottom. Tan of theta, opposite on top, adjacent on bottom. So what I would recommend is, say, on your assignments, your homework, your tests, whatever it is that you're doing involving your trigonometric ratios, I would always recommend to write down SOHCAHTOA on the top of your page. That way you don't have to think about it in your head. Some people, it's hard for them to visualize that. So by having it written at the top of their paper, you guys can just take a quick look and go through each of those ratios and see which ratio matches up with whatever question you're doing. So now we're going to look at example number 1 from your notes. And in this case here, we're going to solve a right triangle. So when we're solving a right triangle, essentially what it says is that we need to find all of the missing sides and angles that we don't have measurements for. So here we have 7, we have 11, and then this box here also tells us an angle, that there is 90 degrees. So what we're missing is angle chem, or angle K, angle N, and side M. So angle K, angle N, and side M. So if you guys want to, we can start with angle K first. And with this one here, I'm going to write theta as K, right in this corner here, and then I'm going to label my triangle. Now I need you to make sure, first of all, it's important to be writing in pencil, but we will have to relabel our triangle, and I'll explain that after we find angle K. So here we have angle K. So our easiest side to label here is our hypotenuse, because it's across from that 90-degree angle. Then we can label our opposite, which is across from that angle. Then the other side has to be our adjacent. So to find angle K, we're working with our opposite and the adjacent. So here we have O and A. So what we want to do is we want to look for the ratio that has an O and an A in it. So looking at SOHCAHTOA, tan of theta has opposite and adjacent. So that means we're going to use the tan ratio to solve. So therefore, we're going to use tan. So I'll start by writing my formula. So I have tan of theta is equal to my opposite over adjacent. And in this case, if you guys can either leave theta as it is, or you can replace it with the letter K. Either way, it's up to you. Just make sure your final answer shows angle K as your answer. So tan of theta is equal to my opposite, which is 11, over my adjacent, which is 7. I want to get theta by itself, so I need to move tan over, which means I have to take the tan inverse of my right side. So tan inverse of 11 over 7. When you plug that into your calculator, you should get 58 degrees as your final answer there. And if you guys have been working with K the whole time, awesome. If not, we're just going to state our final answer here as K is 58 degrees. So now I need to find angle N. So what I need to do is, now I need to go back and erase everything that I labeled before, because if you guys remember what I said in my previous videos, your sides that are opposite and adjacent depend on where your angle is. So now I'm going to label N as theta instead. So according to theta, I guess my hypotenuse doesn't change, so I could have actually left that. So I have my hypotenuse. Then across from angle N is the 7, so the 7 is now the opposite, and then the 11 is the adjacent. So notice how these two sides have changed. So here we have, once again, the opposite and your adjacent. So we're going to be using the tan ratio again. So I'll start once again by writing my ratio. So tan of theta is equal to my opposite over your adjacent. Then I'm going to fill in what I know. So here I have the tan of theta is equal to my opposite, which this time is 7. My adjacent this time is 11. So notice how they've really just kind of flipped their fractions. But that makes a big difference because we're going to get a different angle when we go to solve this. So now I want theta by itself, so I'm going to move tan to the other side, which means I have to use that opposite operation, which is tan inverse. So if you plug that into your calculator, you should get that theta is equal to 32 degrees, and therefore angle N is 32 degrees. So now we need to go and find the last value, which is side M. So this one here is our hypotenuse. And to be quite honest, there's a few different ways that you guys could go about solving this. You guys could use the cosine ratio or the sine ratio now that we have angle K and angle N. But what I would recommend is only using the values that they gave you. So only use the 7 and only use the 11. Because what happens if you made an error in calculating angle K or angle N? So I'd always recommend using the values that you know. So in this case here, to find side M, here we're working with 2 sides and we're trying to find the other side. So we're working with 3 sides in total, which means that we will use Pythagorean theorem to solve. So here we have a squared plus b squared is equal to c squared. And before I move on, I'm just going to quickly redraw a picture of this triangle. So I had here was side 7.0, 11.0, and we had side M here. So if you guys remember with your Pythagorean theorem, it doesn't matter what A and B are. The one thing that's really important though is our C value here. So this C value has to be the hypotenuse. So when I'm looking at my right triangle, it's really important to make sure I've labeled it, which I know we did above, but I'll just label it here again. So here your hypotenuse is side M. So side A and side B, doesn't matter which one. The only one that matters is this hypotenuse. So I'm going to let 7 equal my letter A, and B can be 11. So plugging that in, I have 7 squared plus 11 squared is equal to, and I'll replace C with M, which gives me M squared. Then I'm going to apply these exponents using my BEDMAS. So I have 49 plus 121 is equal to M squared. Adding the two together you have 49 plus 21 is 170. And then we want to get m by itself, so we need to get rid of this square. So to get rid of the square, we have to do that opposite operation, which means we have to square root each side. Then when you square root each side, we should find that m is equal to 13.04, and our units here are centimeters. So we found all the missing sides and angles, so we've completely solved this triangle, which means that we're done the question. And so just as a quick recap, remember guys, I do like to have your angles as the nearest whole number, and then all other measurements, including your sides or anything else that we do in this course, should always be to 2 decimals. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.